Hello students, today we are going to start third lesson from Mathematics Part 1, that is Arithmetic Progression. From this lesson, first we will see the first concept, sequence. So what is sequence? Now on the screen, meaning of the sequence is given. See that. A set of numbers where the numbers are arranged in a definite order like the natural numbers is called a sequence. Means we are arrange the set of numbers in a definite order. That arrangement is called here a sequence. Now see some examples. First example is 1, 2, 3, 4, 5, etc. So numbers start from 1. That numbers are called as natural numbers. So we find out the relation between the consecutive numbers. So what is the relation between 1 and 2? So we are adding 1 in the first position. Which number is given? That is the 1. So 1 plus 1, we are obtain the 2. What is the relation between 2 and 3? Again we are adding 1 in the second position number. The first position number is 1. Second position number is obtained by adding 1 to the first position number. Third position number is 3. So what is the relation between 2 and 3? 2 plus 1. Then we are obtain the third position number 3. So same relation is present between the next consecutive numbers. 3 plus 1, we are obtain the fourth position, that is the number 4. 4 plus 1, then obtain the fifth position number, that is the 5. Then what is the sixth position number? 5 plus 1, then we are obtain the sixth position number, that is the number 6. So in this way, there is a definite order between the consecutive terms or numbers. So this is the example of sequence. And which are of these numbers? Set of natural numbers. All of you understood this? Next. Second example is 1, 4, 9, 16, 25. So if we observe these numbers carefully, so we know that all these numbers are perfect squares. So first position number is a 1. Now see that. First position number is 1. 1 is a square of 1. Second position number is a 4. That is a square of 2. Third position number is 3. That is square of 3. Fourth position number, that is a 16. 16 is a square of 4. 25. 25 is the square of 5. So what is the next position number? So if we observe these numbers carefully, so square of natural numbers and the sequence is formed 1, 4, 9, 16, 25. So after that, sixth position, what number we are getting? That is the square of 6. All of you understood? What is the next one? So 7 square. Next position, that is the seventh position, we are obtain here 49. So among these consecutive numbers, we find out the relation and therefore this is also called as a sequence. Next example number 3. Observe it carefully. 4, example number 3, 4, 8, 12, 16. Find out the relation between the consecutive numbers 4 and 8, 8 and 12. So we are making the addition of 4. 4 plus 4. First position number is 4. We are making the addition of 4. So we are obtaining the second position number 8. 8 plus 4, then we are getting the third position number 12. 12 plus 4, then we are obtaining the next position number, that is the 16, that is the fourth position number. So which number is at the fifth position? So 16 plus 4, then we are getting the 20. Next position number is what? So again we are making the addition of 4, 20 plus 4. So next position number is 24. We are highlighting it. So in this way, this is also called as a sequence because there is a particular relation between the consecutive numbers. That is the addition of 4. Next example number 4 is 2, 4, 8, 16, 32. So find out the relation. Suppose we are making the addition of 2 here. 2 plus 2 means 4. But same relation is present in the next consecutive numbers. So 4 plus 2 means not 6 is there. We are making the addition here in between 4. 4 plus 2 is not 6 there. There is 8. So we are find out the different relation. So what is the relation? See there. 2 multiplied by 2. Multiplication is there. 2 multiplied by 2. Then we are obtaining the second term, that is the 4. 4 multiplied by 2. Then we are getting the 8. 8 multiplied by 2. Then next fourth position number 16. 16 multiplied by 2. Then we are getting the fifth position number 32. What is the next position number? So 32 multiplied by 2. Then we are getting the sixth position number, that is the 64. So this is the relation between the consecutive numbers and forming the sequence here also. Next example number 5. Check that. 4, 16, 64. So what is the next number? We find out that. So we are not making the addition. Check that. 4. What is the relation between 4 and 16? 4 4s are 16. 4 4s are 16. Next relation is 16 4s are 64. That is the third position number 64. So what is the fourth position number? So 64 multiplied by 4. So answer is 256. Therefore, this is also an example of sequence. Next example 1, 4. See in this sequence 1, 4, 7, 10. What is the relation? So 1 addition. 1 plus 3, then we are getting the next position, second position number 4. 4 plus 3, then we are obtaining the third position number 7. 7 plus 3, then we are obtaining the number 10, that is at the fourth position. So what is the fifth position number? 10 plus 3, then we are getting 13. 13 plus 3, then we are getting 16. And so on. So this is also an example of sequence. Next. Seventh example is 3, 3, 3, 3. So what is the next number? So we are getting the next number is also 3. So what is the relation between all these three terms? First term is a 3. 3 plus 0. We are getting the second term 3. Again 3 plus 0. Third position number 3 is obtained. Again third position number 3. 3 plus 0. Then fourth position number is also 3. In this way, we are making the addition of 0 and to form this sequence. And last example number 8. Cube of 1. Yeah, 1 raised to 3. Raised to 3 means nothing but the cube. 1 cube, 2 cube, 3 cube, 4 cube. So what is the next term? 5 cube. What is the next term here? That is the 6 cube. Next one is 7th cube. So all these are the examples of sequence. Remember, observe this carefully. So in all these 8 examples, all are examples of sequence. From above examples, a particular sequence, that is a example number 1, 3, 6 and 7. Check now. 1, 3. What do you observe in 1 and 3? In example number 1, we are making the addition of 1 in the previous term and then to obtain the next term. In third example, addition of 4 in the previous term, then obtain the next terms. Then in sixth example, addition of 3, then to obtain the next terms. And in example number 7, we are making the addition of 0, then to obtain the next terms, 3, 3, 3, like that. And therefore, from all these above examples, a particular sequence are 1, 3, 6 and 7. In this sequence, same relation is used in consecutive numbers. Same relation is used in consecutive numbers are called arithmetic progression, that is in short AP. So this is the concept of arithmetic progression, that is difference between the consecutive numbers is required same. So that type of sequence are called as arithmetic progression. Next concept we learn in this lesson, that is definition of arithmetic progression. Say it carefully. Definition of arithmetic progression, in short that is AP. In the given sequence, if the difference between two consecutive terms is constant, then the given sequence is called as arithmetic progression, or in short AP. Very simple meaning of arithmetic progression is given here. In the given sequence, if the difference between any two consecutive terms is constant, then the given sequence is called arithmetic progression, in short AP. Now see that. Now we are solving some examples related to this arithmetic progression. Example number 1. Now we are decide this given sequence is AP or not. This given sequence is AP or not. Now see how to solve the given question. In the given sequence, what is the given sequence that we write first in our answer? 5, 12, 19, 26, dash, dash, and so on. So, according to the position of this, 5 is at the first position, so called as the first term, indicated as a T1 is equal to 5. 12 is at the second position, called as the second term, that is equal to 12. 19 is at the third position, so that is called as the third term, T3 equal to 19. 26 is at the fourth position, that is called as the fourth term, indicated as a T4 equal to 26. So 5 is the first term, second term is 12, third term is 19, and fourth term is 26. Now, as per the definition of arithmetic progression, we are find out here the difference between the two consecutive numbers, all terms is same or not. And therefore, we are find out like this answer. Therefore, we find the first difference, that is the T2 minus T1. What is the difference between T1 and T2? So, formula we are use here, T2 minus T1. So, what is the T2? Second term is 12 and first term is 5. So, 12 minus 5, we are obtain the 7 here. Next difference we find out, that is T3 minus T2. T3 is 19, check there, and T2 is 12. 19 minus 12, again we are obtain the answer, or difference between third and second term is 7. And one more difference we find out here, fourth term minus third term, that is T4 minus T3 is equal to fourth term is 26 minus third term is 19. 26 minus 19, again we are obtain the answer 7. So in this given sequence, the difference between the consecutive terms is same, that is the 7 in all this, and therefore we are writing in this way. Final answer. Therefore, the common difference indicated as a letter D. Common difference D between two consecutive terms is a constant. What is that constant? Here we are getting the 7, and therefore at the last, that is D is equal to, what is that D? D means nothing but the value 7, and that difference is, common difference is, we are finding out T2 minus T1, that is equal to T3 minus T2, that is equal to T4 minus T3, that is the answer 7. And therefore finally, if we are getting the answer of common difference is same in between any two consecutive term, that is a constant, and that's why from this our answer, at the last we are writing the answer, the given sequence is an AP, and highlighting our final answer. All of you understood? This is the first question. Now from the problem set 3.1 we are solving few more examples. In question number 1, check that. In question number 1, which of the following sequences are AP? If they are AP, find the common difference. Check that. The example number 3 given here, that is a minus 10, minus 6, minus 2 and 2 and so on. Our answer is, in the given sequence, we are writing that given sequence, minus 10, minus 6, minus 2 and plus 2 here. Next, so minus 10 is the first term, that is T1 is equal to minus 10. Minus 6 is the second term, that is a T2 equal to minus 6. Then minus 2 means nothing but the third term, that is T3 equal to minus 2. And 2 is at the fourth position, that is the T4, that is fourth term is equal to 2. Then we are finding out the difference. T2 minus T1, first difference. See that. Second term is minus 6 minus first term is minus 10. So this minus sign is this one. Minus sign in between T2 and T1. Our first term is minus 10. So that we are writing in bracket. So minus of minus 10 means nothing but plus 10. So minus 6 plus 10 means nothing but 10 minus 6. We are getting the answer 4. Next difference is T3 minus T2. Now third term is minus 2. Clear? Minus. Second term is minus 6, that we are substituting here. So minus of minus plus. So minus 2 plus 6 means nothing but again 4. And one more difference, T4 minus T3. The difference between the fourth term and third term, that is T4 minus T3, that is fourth term is a 2 minus our third term is minus 2. Minus of minus plus here. So 2 plus 2 is again answer 4. So what we observe here? Common difference between any two consecutive numbers or terms is the same. And that's why final answer we are writing like this. Therefore, common difference, see the final answer. Common difference D between two consecutive terms is a constant, that is D is equal to what? 4, and this difference we find out with the help of T2 minus T1, that is also equal to T3 minus T2. Out of these three, write any two, first two. First two differences are same, then obviously next differences are also same. So any two differences you find out, and finally we are writing like this, T2 minus T1, that is equal to T3 minus T2, that is nothing but difference 4, and finally we are writing here the given sequence is an AP and common difference is 4, like this. All of you understood? So see that some examples are given in our textbook for our practice purpose. Try to solve the given examples. Now we see one more example. Example number 7. Check carefully what is given here. First term is 3, second term is 3 plus root 2, third term is 3 plus 2 root 2, next fourth term is 3 plus 3 root 2 and so on. Now answer. In the given sequence we are writing here. So what is the T1? First term is a 3, second term is 3 plus root 2, T3 means third term is equal to 3 plus 2 root 2. Fourth term T4 equal to 3 plus 3 root 2. Then find out the difference. T2 minus T1 is equal to, what is the T2? 3 plus root 2 minus first term is 3, that is minus 3. So plus 3 minus 3 cancel, only root 2 is remains. All of you understood? Next difference is T3 minus T2. What is the third term? 3 plus 2 root 2 minus, in bracket we are writing the second term is 3 plus root 2. Now before the bracket minus sign is there, and if we are removing this bracket, change the sign of the terms present in bracket. So 3 also plus and root 2 also plus, so both the term sign change, minus 3 and minus root 2, check there. Yeah. So 3 plus 2 root 2 minus 3 minus root 2 plus 3 minus 3 0, 2 root 2 minus root 2. So again we are obtain what? Only single root 2. 2 root 2 minus single root 2, answer is 2 root 2. One more difference, that is T4 minus T3 we find out. Fourth term is 3 plus 3 root 2 minus third term is 3 plus 2 root 2 is equal to, we are removing this bracket, so change the sign because before the bracket minus sign is there. So 3 plus 3 root 2 minus 3 minus 2 root 2. So plus 3 minus 3 cancel, and 3 root 2 minus 2 root 2, again we are obtain the answer root 2. So first difference is root 2, second difference also root 2, and third difference is also root 2. So common difference is same. So finally we are writing the answer. Therefore, common difference D between two consecutive terms is a constant. Therefore, what is that value D? D is equal to root 2. That is equal to what? T2 minus T1 is equal to T3 minus T2. And therefore, the given sequence is an AP and common difference D is root 2. We are highlight our final answer in this way. All of you understood? So, this is a pattern to solve the given sequences are AP or not. If they are AP, that given sequences are AP, then write down the common difference, value of common difference, that is D is equal to what? Next, we are solving question number 2 from this practice set 3.1. What is the question given? Now see that. Question number 2. Write an AP whose first term A and common difference is D in each of the following. Means we are writing an AP. And what is given in all questions? First term, that is also indicated as a letter A, and common difference is indicated as a letter D. Means value of first term and common difference is given, and we are forming the AP. Now answer. Given first term A is equal to 10 and common difference D is equal to 5 given. Therefore, T1, that is the first term, means nothing but is equal to A, that is equal to 10. So we know that which sequences are called as AP or arithmetic progression. So common difference between the two consecutive terms is same. It means we are obtain the next term. For example, second term. So what is our operation? First term plus common difference. We are obtain the third term, then we are adding common difference in the second term. That relation we are use here. So we find out the second term. Second term T2 is equal to, we are adding that common difference in previous term, that is a T1. We are find the second term, so adding the common difference in first term, that is T1 plus D. So first term is 10, T1, value of T1 is 10 plus common difference 5. So second term we are obtain here 15. First term is 10. Next, how to obtain T3, which is the previous term, that is T2, T2 plus common difference. So second term we obtain here 15, check this, 15 plus common difference 5, 15 plus 5 means 20. T4 we find out here, T4 equal to, which is the previous term, that is third term, T3 plus common difference. So T3 is a 20, check here, plus 5, that is common difference. 20 plus 5, that is 25. And therefore, finally, we write the answer. Therefore, AP is equal to, first term is a 10. Check now here. I will show the final answer. This is our AP. First term is a 10. Second term is 15. Third term is 20. And fourth term is 25, comma, and so on. Finally, we are writing our answer like this. Right, and AP. So this is our AP if first term is equal to 10 and common difference 5 is given in this question. All of you understood? Now we will see few more examples. Check that. Example number 4. First term A is equal to minus 1.25 and common difference D is equal to 3. So answer, given A is equal to minus 1.25 and value of D is equal to 3. Therefore, T1 is equal to, that is first term. First term means nothing but the A. So first term means nothing but A, and that is already given in question, minus 1.25. So how to find out the second term? We are adding the common difference in the first term. We find out the T2, that is second term. So which is the previous term? The first term. So T1 plus D. Value of T1 is minus 1.25 plus common difference plus D plus 3. So minus 1.25 plus 3 means 3 minus 1.25. We are doing the subtraction. We are getting the second term, that is the 1.75. Next, we find out the T3. T3 means we find a common, we are adding the common difference in the previous term, that is T2. T2 is, we are obtaining here, T2 means nothing but 1.75 plus common difference is 3. So 3 plus 1, that is a 4, 4.75. This is the third term. And fourth term is T3 plus common difference. Our fourth term is 4.75 plus 3. So 4 plus 3, that is 7.75. This is the fourth term. And finally, we are writing our answer. Therefore, AP is equal to, first term is minus 1.25. Second term is here 1.75. Third term is, check here, 4.75, and fourth term is 7.75, and so on. In this way, we are forming the AP if first term and common difference is given. We are writing the arithmetic progression. We are forming the arithmetic progression or AP if first term and common difference is given. Next. All of you understood? We are solving one more example. Now see that. What is given in this example? Example number 5. First term A is equal to 6 and common difference D is equal to minus 3. Now answer. Given A is equal to 6 and D is equal to minus 3. Therefore, T1 means first term. First term means nothing but A. A is also represented for the first term. So T1 is equal to A is equal to 6. T2 is equal to what? How to find out T2? So we are adding common difference in T1, that is first term, T1 plus common difference. Our T1 means first term is 6. 6 plus our common difference is minus 3, that we write in bracket. So plus of minus means nothing but minus. So 6 minus 3, that is equal to 3. That is second term. Third term is T3 equal to T2 plus common difference. So our second term is a 3. 3 plus our common difference is minus 3. So plus of minus minus. So 3 minus 3 is equal to 0. This is our third term. And one more term we find out T4. T4 is equal to T3 plus common difference. So our third term is a 0 plus common difference is of minus 3 plus of minus minus. So 0 minus 3, answer is minus 3. And therefore, finally, we are writing the answer. Therefore, AP is equal to, first term is 6, second term is 3, check here, third term is 0, and fourth term is minus 3, and so on. In this way, we are forming arithmetic progression when in question first term value is given and common difference is also given. So remaining questions, options from this question number 2 of practice set 3.1, you try to solve, that is for your homework. Now question number 3. These are the variety of questions given here. This is the last type of question. Question number 3. Find the first term and common difference for each of the following AP. Means following sequences are already AP. Clear? And then we find out first term and common difference. So how to find out the answer? Now check here. Our option number 2. First term is 0.6, second term is 0.9, third term is 1.2, and fourth term is 1.5. Now answer. In the given AP, already this sequence is already AP, that is arithmetic progression. So we are writing like this. In the given arithmetic progression, or in short AP, that we write here, that sequence, that AP already as it is we are writing here 0.6, 0.9, 1.2, 1.5, etc. and so on. So first term, what is the first term? Check. 0.6. So we are writing here T1 is equal to A is equal to 0.6. We are finding out the difference, that is common difference, so only write the second term because this sequence is already an AP. So only one difference we find out, that is the difference between first and second term. So T2 is what? 0.9. And therefore, so our first term T1 is equal to what? A is equal to 0.6 and difference D is equal to T2 minus T1. What is the second term? 0.9 minus first term is 0.6. So 0.9 minus 0.6, our common difference is what? 0.3. And finally, we are writing the answer. And therefore, first term A is equal to 0.6 and see here. Is it right? And common difference D is equal to what? That we write here. Therefore, and common difference is equal to D is equal to 0.3. We are highlighting our final answer. We are highlighting our final answer in this way. So in this way, these are the 3 varieties of questions given in this practice set 3.1. So remaining options all for your homework. Try to solve with the help of these today's solved question in our today's video. Thank you.